We've learned about intermolecular interactions in this chapter. Those are the interactions that hold different molecules together. For instance, there are intermolecular interactions that hold water together to make liquid water. We call these hydrogen bonds, and they exist all through nature. We'll see an interesting demonstration of this. I have two chemicals here. One is essentially white glue, and we'll pour some into this container. And one is a chemical which joins the long chains of molecules in that glue together. We call that cross-linking. It forms hydrogen bonds between the strands. So we'll take this and we'll start to mix it by pouring it back and forth between the containers. And very quickly you can see that it's changed its state from a liquid into a gel. We can pour this gel out into my hands, and we can see that it sticks together some, but it still flows. You've experienced things like this before in your life. You've dealt with honey. Honey, if you try to move it very quickly, acts like a solid, but if you're willing to be a little bit patient, it turns into a liquid. Its unique properties have to do with these hydrogen bonds. Each of them individually is weak, and so if I wait, I can break and remake those hydrogen bonds, and it will flow like a liquid. However, if I try to break all of those hydrogen bonds at the same time, it acts like a solid. The DNA in our cells is held together by hydrogen bonds. If you try to break DNA apart all at once, it takes a lot of energy. But if you carefully unzip it one bond at a time, you can split it into the two parts necessary to reproduce cells.